Now we have some probability questions, but before starting the probability, let us remember some rules. Probability of any event A can be calculated as by using the formula number of the favorable outcomes to A, the desired event, how many times it's being, and then total number of outcomes. So by using this formula, we can solve lots of questions. And then secondly, this one we haven't studied yet. We will study inshallah next week. Now, this one we have studied and we may use in our questions the probability of A or B. This is the symbol to say or. This is the symbol to say and. A or B is equal to PA plus PB minus PA intersection B. So, if two events are mutually exclusive, it means that they do not have the common area, which means these two events cannot be at the same time. It will be empty set, so it will be 0. The formula directly will be PA plus PB. But if something is not mutually exclusive, that means that if there's an intersection, we will use this formula. And this is also we will study next week. Now, let's go back our questions. So it says that a family has 3 kids. It's important. By referring to a given table, so this table is given, even this is not given, we can say that the table BBB, BBG, and BGB, BGG, we have talked about this by using probability tree, and GBB and GBG, GGB and GGG refers girls and B refers boys. So it says that what is the probability of exactly 3 boys out of 3 children? And so it means that we have only this, right? B, 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 all of them are boys out of the 3. Only one case. So if you remember the formula, we said that number of the favorable outcomes, which is 1. So we can write here answer of part A, 1, or probability of A is equal to 1 over total number of outcomes. So totally how many outcomes we have? 8 different cases we have. So 1 over 8. And then by looking at this, first of all, we can eliminate this one. So the answer is starting with 1 over 8, 1 over 8, 1 over 8. Now the part 2. What is the probability of exactly 2 boys out of 3 children? So 2 boys out of 3 children. So here 3 boys we count. 2 boys out of 3 children, yes. 2 boys out of 3 children, yes. Here, no. Here 2 boys out of 3, yes. And 2 boys, no. Just these are. So 1, 2, 3. Probability of this event, if I call this event B, 3 over 8. So where I have 3 over 8 in this part, so answer is directly this one. If I call this is, this is the answer. What about the part C? To be sure, let's solve. What is the probability of exactly 1 girl out of 3 children? 1 girl here? No. 1 girl? Yeah. 1 girl out of 3. So this could be 1 girl out of 3. This could be. This is no. Why? There are 2 girls. This is yes. There's only 1 girl. Could be. And 2 girls. So no. 2 girls. No. 3 girls. No. So how many? 1, 2, and 3. So if I call this is event C, which is being 1 out of 3 girl, it is 3 over 8. So the answer must be 1 over 8, 3 over 8, and divided by 3 over 8. Do we have this? If not, so we have to look at 1 minute. Interesting. Interesting. Why interesting? At the beginning, I have directly eliminated none of above since I have seen 1 over 8, 1 over 8, 1 over 8. But what I see in the last case, what is the probability of exactly 1 girl? So exactly 1 girl is 3 over 8. So 3 over 8, yes, here it could be. Yes, here it could be. And Here it's not possible, the last one, so I eliminate this one. But the second part, 1 over 8, and the second part should be 3 over 8, so this is not 3 over 8, I have eliminated. This is not 3 over 8, I have eliminated. So the answer is only none of above, which means this is the answer. So the answers are 1 over 8, 3 over 8, and 3 over 8 in order. Okay, let's go for another question. If one of the 99 test subjects is randomly selected, what is the probability of getting a subject who is pregnant? Use the given table. Who is pregnant? So when we look at here, dear students, subject is pregnant. So 63 plus 2, which is 65. So, and whenever you have a table question, it's better to find the totals. 4 plus 30, which is 34. And 63 plus 4 is 67, 2 plus 30, 32, so 67 plus 32 or 65 plus 32 should be the total, which is 99. Even 7 plus 9, 2, 6 plus 3, 9, correct, 5 plus 4, 9, 6 plus 3, 9, correct. So we just double check. And in the question it is also given 99 subjects. And then the probability of any event, what was the number of favorable outcomes of A divided by total outcomes. So the favorable means the event which I want to see. So which event I want to see? Getting a subject who is pregnant. So the pregnant, how many here? 63. How many here? 2, which is total 65. So 65 divided by total number, which is 99, is the answer of the question. And please be careful about this. So positive test result, negative test result. So we are not caring about when the result was positive and in reality she is pregnant, or when the result is negative in the reality she is pregnant. No, we are just simply looking at how many of them are pregnant without any condition. Okay, conditional probability we will study for the following weeks, and there will be different questions. It could be that what is the probability of getting a subject which is pregnant, where it's given that his or her test was positive or her test was negative. This is conditional probability, but there is no condition. You're just simply asking number of pregnants probability. So this is 65 over 99. So similar to this question, same table, it says that subject is not pregnant. So there are two cases. The first solution is subject is not pregnant means this total, which is 34, 4 plus 30, 34, divided by the sample space, which is 99. So this is the answer, which is here. Or second solution, we know that to see the one event not occur, we have a general rule, PA plus PA complement is equal to 1. So I can say that in the previous question it was 65.99 to be a pregnant. So not to be a pregnant is my question. So it is equal to question mark is equal to 1 minus 65 over 99. So which will be 99 minus 65 divided by 99. So which will be 9 minus 5, 4. 9 minus 6, 3. 34 over 99, which is here. Of course, they are both same. This is another way, if you wish, you can use. Now another question. A research center poll showed that 81% of the people believe that it is morally wrong to not report all income on tax returns. So event A, not report, blah, 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 and its percentage is 81, and 81 means by the way 0.81. So what is the probability that someone doesn't have this belief? So which is complement of this. So the way is so simple, PA plus PA complement, it's always 1. So this belief, it's supported by 81% of the people. So 0.81 plus who is not or who doesn't support this belief, it's complement, which is 1. So it will be 1 minus 0.81. So it will be 0.19, where the answer is this. And then, similar to previous question, determine the written description of the complement, so this one, of the given event. So PA complement, it's our question. So what is the event? When 9 job applicants are examined, at least one of them tests negative. So A, at least one of them negative. Out of what? Out of 9 results. So it means that 1 result negative, 8 positive could be. So 1 negative, 8 positive could be. Or 2 negatives, 6 positives, 7 positives could be. Or 3 negatives and then 6 positive could be. Or 4 negatives and 5 positive could be. 5 negative, 4 positive could be. 6 negative, 5 positive could be. 7 negative and 5, 4, actually this is 3. So let me clean and write it again. I think you understand the logic, it's simple. And then 5, 4 and 2 positive. Why? 7 plus 2 is 9. Or 8 negative 1 positive. Or 9 negative 0 positive. So how can I express this? Probability of 1 negative 8 positive or 2 negative 7 positive or blah 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 up to where 9 and 0 positive. And then I can use the formula, but it is very, very, very long. Instead of this, what am I going to do? I will do this one. So PA plus PA complement is always 1. So what can I say then? So if the thing is, you see that I want to see minimum 1 negative. It could be 2, it could be 3, it could be 4. I mean, at least there must be 1 negative. So what is the opposite of this? None of them negative. What does it mean? So what does it mean? 9 of them positive and 0 negative. This is the case complement. So do I have here none of them test negative and none of them test negative. So answer is this one. Finished. That's it. Okay. If it's not so clear, I strictly recommend you to read the question again and to think about the meaning of complement. So whenever you have at least, that means that minimum 1. And so what is the opposite of this? At least minimum 1 and nothing. Okay. Good. Do we have any other question? Yeah. Decide whether the following two elements are disjoint. What does disjoint mean? Set A and set B events cannot be at the same time. This is a definition of disjoint. So, randomly selecting someone who smokes cigarettes. So this is the now smoking cigarette, let's say, and then randomly selecting a male. So smoking cigarette could be male here, or smoking cigarette could be female here. There could be, intersection part even for the male, even for the females. Okay, so are the two events disjoint or not? Yes, because the events cannot occur at the same time. No, it could be occur at the same time. When I choose anyone randomly, this anyone could be male and it could be smoking. Of course, the opposite is also possible, but we are talking about in general. No, because the events can occur at the same time. If they're occurring at the same time, it means that they have intersection, then the sets are not disjoint. The sets are joint set. And for that reason, it's not possible. Yes, because the events can occur at the same time. We said it's no. No, because the events cannot occur at the same time. So this is also wrong. So which one? The answer should be with the yes. So just let me clean this part. When I was reading, I didn't concentrate. Well, so let's have a look one more time. So logically, it is possible the someone which is randomly chosen could be male and smoking. So do we have, for that reason, these sets are not disjoint. Are the two events are disjoint? No, they are no. So yes cannot be we said. Yes cannot be we said. So the answer must be first no. Just the reason we have to take care. So what is the reason? No, since events can occur at the same time. Yeah, that is the answer, which is I have shown here. Being a male and smoking at the same time could be occur. So for that reason, these sets are not disjoint. I mean, smoking and being male have a intersection, the common area. So these sets are called joint sets. Okay. Yeah, that's it. I hope everything is clear. You understood. If there's any problem, you can tell me. You can make a comment and ask me on that YouTube channel. I will try to answer your questions as soon as possible.